Okay, day 3 of 6.2 notes. So today we're going to be looking at that average value component. These problems are very straightforward. I don't want you to overcomplicate them. What average value literally means is that we are finding the average y value or height of the function given. So if we are talking about a word problem, it has some meaning. If we're not, like this first example we're going to do, it is finding the average height of the graph during the time interval given, or the distance interval given. So here, average value of an integrable function, f of x on the closed interval from a to b is the quantity of 1 divided by b minus a times the integral from a to b of f of x dx. This is the same exact idea as we saw back in the derivative chapter, if you recall it, when we used to talk about when is the secant slope equal to the tangent slope, right? When is the derivative equal to change in y over change in x? This is the same as having change in y over change in x. This is a slope. So I'm getting a little bit more into what we actually have to, but in terms of understanding, this might be helpful for some of you. So remember that an integral takes little f and returns it back to big F, and it evaluates f of b minus big F of a. Right? That's what the integral part is equal to. So we have original y value, change in original y value is the f of b minus f of a. Change in the x value is the b minus a. That's literally our slope formula that we learned, years ago. Okay, so in these problems, they're as simple as take your function and your interval and set up what the formula tells you. 1 divided by pi minus 0, integral 0 to pi sine x dx. Okay, you can put it in your calculator. Some of these are easy enough you might choose to do it by hand, but you don't have to. So it's 1 over pi multiplied by the integral from 0 to pi sine x dx. I'll go to Desmos. First I'll put 1 divided by pi, and then we have the integral from 0 until pi of sine x. Oops, this probably is not where I want to go. Functions, trig, sine x dx. Okay, the only thing I want to check, I'm not sure. Okay, good. I'm in radians for this, so this is correct. 0.64. Okay. So again, if we looked at the meaning of this, let me go back to Desmos. Oops. If we look at the graph of sine x, and we only focus on 0 to pi, roughly 0 to 3.14, so you can see the curve up above in the first quadrant. The average value is saying during that curve, what's the average height of the graph? So we go all the way up to 1, right? We go down to 0, but on average, it's about 0.64. Second one. Again, just as simple as take your function, 1 over b minus a out in front, 1 over 0 minus negative 1, so it goes to plus a positive, from 0 until negative 1, of x to the 5th minus 2x cubed plus x dx. So the 1 over b minus a part is just a 1, so we don't really need that. So 0 to negative 1, oops, parentheses, was it x to the fifth minus 2x cubed plus x. And that's 0.17. Okay. Same thing here. Integral 1 over 1 minus 0 from 0 to 1. Ooh, wait a minute, I just caught a mistake. Yes, I did catch a mistake here. I should have, let me go back, I'm glad I caught this. I should have put negative 1 on the bottom to 0 on the top. Now my hunch is that, right, I should just have the same answer except for it might be negative instead. So let's go back and edit this. Zero goes up top. Right, so I'm just changing the direction. I'm reversing my limits of integration, which means I should have exactly the same answer, but negative. Sorry about that. Okay, back to this one. So we have negative x to the fifth plus 3x cubed dx from 0 to 1. Hello. 0.58. The only reason I'm not putting that 1 over b minus a in the calculator is because the last two problems, they just turned out to be, 1 over 1. Okay, so here's a little bit of context here. An object with 0 initial velocity accelerates at a constant rate of 10 meters per second squared. So that's the acceleration. We need to find its average velocity. Okay, average velocity. Therefore, we need to be doing 1 over b minus a with the velocity function in order to do this. Whatever equation or whatever value they want you to find the average of, that's the representing function that you need, okay, during the first 15 seconds. So we're going to need 1 over 15 minus 0 over 15 from 0 to 15, and we need to figure out what that velocity function is. So we have to do a little bit of work. Well, if we know the acceleration, and we know that if we integrate an acceleration, we then get to a velocity. So 10 integrates back to 10t. And that's why they needed to tell us that there was no initial velocity, so there's no plus c here. We don't have to worry about that. So our velocity is 10t. So then we can 1/15, 0 to 15, 10t dt. And you get 75. And that would be meters per second for velocity. Okay. just going to do one more here. We'll do the grass clippings. So grass clippings are placed in a bin where they decompose from 0 to 30. The amount of grass clippings remaining in the bin is modeled by this. So this is an amount. Find the average amount. So in this case, we're given the equation we need. We know the interval. And we put the 1 over b minus a in. Right. So the a of t equation represents the amount of grass clippings in the bin on a certain day. We want to find that average amount. So we have 1 divided by 30, integral 0 to 30. Now, what was that equation? 6.687.931. To the x power dx. Okay, I shouldn't need parentheses, but I'm going to go back just in case and put parentheses there and there. Yeah, that's fine. All right, so 2.75 pounds of grass is the average amount on any given day. Right, so from day 0 until day 30, they average 2.75 pounds in there on any given day. Okay, so like I said, this idea is not the main focus. For your quiz, I think I'm only giving you problems like the straightforward ones out in front. You have a worksheet to practice. The main focus of this section is being able to, like day 1 and day 2 notes, being able to graph the base and then, depending upon what the cross-section is, come up with the area of a cross-section and integrate in both directions. So we saw that we moved horizontally, which meant an x equals equation, and we saw that we went vertically, which meant a y equals equation. Okay, so I'll be posting this video, or obviously if you're listening to me right now, I've already posted it. You have the worksheet and the quiz to do next week, okay? And then we have one more section to finish before we can safely say we've covered the majority of the calculus curriculum, and we can move into our projects, okay?